Okay, welcome back, algebra students. We're in chapter 6 now. Chapter 6, and we're talking about graphing systems of equation here in section 6.1. We're going to determine the number of solutions of a system and solve a system of equations by graphing. So the first thing we're going to talk about here is just kind of looking at some review, sketching these graphs. So we just got to remember how to graph on here. So the first one, we're nice and easy here. We're already in slope-intercept form. So we've got a slope of negative 1/3 here, and then b is our positive 4. So when we graph this one, it's fairly simple. We're going to go up 4 on the y value. We're going to begin with our b, so 4, and then we're going to go down 1/3, down 1/3, and we have a nice little line there. And just make sure it's nice between them, between those points, and we're good to go. Put arrows on there. Extend it, and we're in great shape. Okay. The next one, it is not in slope-intercept form, so we want to get it into y equals mx plus b. So basically, I'm going to take my 2x. I'm going to subtract 2x here. If you remember, you can write that 2y is going to come down because these are going to cancel out. You can write it negative 2x plus 8 or 8 minus 2x, but I like to write it like this because then it's in closer to slope-intercept form. And then the last thing we'd have to do is divide here by 2, everything. So that we know those 2's cancel out, and we're left with y equals a negative 1x plus 4. So here, when we look at this, we end up with, again, we're starting at 4. Now we've got a b value here of 4 as well, and our slope, and this one is negative 1, or you could say negative 1/1, rise over run style. So again, I'm going to start here at positive 4. I'm going to begin with my b, positive 4, and then I'm going down 1/1, down 1/1, down 1/1, and so I've got my slope there. I'm going to build my line through it. I don't like that one. Let's try it again. There we go. That's a little bit better. Okay. And again, I can extend and put arrows on it. And I'm in good shape. Okay. So all I really did was graph 2 lines, 2 equations on the same coordinate axis system. No big deal. But if you look at our objective here, what we're trying to do is we're going to try to determine the number of solutions, and then we're also going to solve a system of equations by graphing. Okay, so let's talk first a little bit about what a system of equations is and what a solution is. And then we'll come back to this example just to show you the solution. So first, what is a system of equations? It's 2 or more equations. At least 2, you might have more than 2. And then when we talk about a solution, what we're talking about here is it's an ordered pair that satisfies both equations. So again, what does satisfy mean? In math terms, it means it makes it true. Makes it true. Okay? And then what we're looking at here then is the point at which the lines intersect. That's going to be the solution. Okay, so go back here. What satisfies both equations on our example here? Well, it would be this point right here is where it intersects, where it crosses. That's your solution. Where it intersects would work for both lines. And so we name it by an ordered pair. So in this case, we're 0, 4 would be our ordered pair there. So going back to what we said here, 2 or more equations, and the solution is the ordered pair that satisfies both equations. Basically what we're looking at is this is the point where the lines intersect. Points where the lines intersect. And so our solution in that last example was 0, 4. Okay? All right, so let's talk a little bit about what we talk with systems of equations and what type of solutions we can have and the terminology behind it. So we just did an example where the lines intersect. So that's example 1 where you could have intersecting lines. And we would know that the point where it's intersects is a solution. So it would have exactly one solution. In this case, it would be right here where they intersect. And then the terminology, not really important. It's technical stuff. We call this consistent and independent. Okay. The second example, what you could have is the same line. You could have two equations that are the same line, two or more equations that are the same line. And in this case, the line would always be touching because it's the same exact line. So if it's always touching, then it would have infinitely many solutions because it would go on forever and ever and it would always be touching. So infinitely many. And again, the terminology here is consistent and dependent. The lines depend on one another to be the same line over and over. And our last one, our third example you might see are parallel lines. If you remember back from a few chapters ago, parallel lines have the same slope, and so they'll never cross. So if they never cross, they'll have no solution. And we can feel free to use our no solution symbol. And our terminology here is inconsistent. So those are what you're going to have. You're either going to have one solution, infinitely many solutions, or no solutions based on how many times it crosses, how many intersection points there are. So moving to this type of problem. Use the graph at the right to determine whether each system has no solution, one solution, or infinitely many solutions. So what we're trying to do here is we're asking the question of how many solutions. So in this case, in this example, they did all the work for us. They did all the hard work for us. They did all the graphing over here in this grid. We just have to look and see how many solutions there are for each of these examples. So the first one here, in letter A, we've got y equals negative 2x minus 5, and then y equals negative x minus 5. Well, it's also great that they're already in slope-intercept form, y equals mx plus b form. So if we look at these graphs, if I was going to point these out, what I'm looking for is the first one, negative 2x minus 5. Well, that's here. That's this red one right here. Okay, so we could look at that one. And the second one is x minus 5, y equals x minus 5. So that's this purple one down here. So when we look at these, where do they cross? Do they cross? And if they do, where is it? Well, it looks like if we follow this line down here, and then we draw this line here, it looks like they're going to cross right up here. So this is our solution point right here. So it has crosses. So this one would have one solution. One solution. And we don't have to name it every time, but we're going to. I'm going to go ahead and name it for us, okay? Because we can name that intersection point. If we looked at what the axis was, I think here's our x-axis, here's our y-axis. Looks like it's at 0, 0 on the x, and y would be what? 1, 2, 3, 4, 5, 0, 5, 0, negative 5. It's not always going to be 0. It's just kind of worked out that way on our two examples. Okay, would be the solution. Okay, now I'm going to clear this stuff off for us again because we're going to look at two more. If we look at, again, negative 2x minus 5, so that's that same one we were dealing with before, this red one, negative 2x minus 5, and then negative 2x plus 3. That's this blue one right here. Okay, that's this blue one. All right, well, if we take a look at these two lines, or I'm sorry, it's not the blue one. I believe it's the, yeah, it's the green one down here. Good, okay. Whoa, didn't want to do that. It's this green one here. Okay, there we go. Now we're on target here. So if you look at these two lines here, we've got the red line and the green line. And what do we notice about them? Do they have a solution? Do they have no solution? Well, if we look at their slope, they have the same slope of negative 2. They have the same m value. And if you remember about things with the same m value, they're parallel. They don't have, they will not cross because they're parallel because they have the same slope. So we could say they have no solution, and the reason being that they're parallel because they have the same slope. All right, and the last one here is a little bit tricky. We're going to look at 2x plus 3, which is this blue one up here, this blue graph. And then we're going to look at y equals x minus 5. That's the purple one again. Okay, so if we were to look at these two graphs, on our graph they don't intersect, but they do have different slopes. So that's why the arrows are important, because if we continued this graph on and we continued this one on, they may cross somewhere down here. Okay, but we can tell that because they don't have the same slope, they are going to cross. So they do have one solution. We can't really tell right now what the solution is because it's going to be down here off of our graph. But in this case, we know it does have one. They're not parallel, and they're not the same line. So they have one solution. All right. Let's take a look at an example here of solving by graphing. So then determine whether it has no solution, one solution, or infinitely many solutions. If it has one solution, let's name it. And there is one thing we have to talk about here, and it's you must use graph paper to find a solution for a system of equations. You have to, because it's just going to be a situation where it's you have to be precise. And if you're just sketching it on paper, your point's a little bit off, it's not going to quite work for you. All right? So the first one should be pretty simple here because they're both in slope-intercept form. So this first example, we've got a b value of 8, and we've got an m value of -1. So we can easily graph that one. 1, 2, 3, 4, 5, 6, 7, 8 is here. And we're going down 1 over 1, down 1 over 1, down 1 over 1, and I can easily sketch a line through there. Try to make it as neat as possible. And then I'm going to put my arrows on, and I'm good to go. Okay. The next one we also know has in y equals mx plus b form. It's got a b of -7, and it's got an m of 4. So in this case here, I'm going to start down at -7, 2, 3, 4, 5, 6, 7, and my b value, and I'm going up 4, 1, 2, 3, 4 over 1, up 4, 1, 2, 3, 4 over 1, up 4, 1, 2, 3, 4 over 1. Okay, and then I'm going to connect those dots there. And then draw arrows to extend, and we're in good shape now. So now we just have to look, how many solutions does it have? Well, it has one solution, and that would be right here at this intersection point. So it has one solution. That was the first part of the answer. Does it have one solution, infinitely many solutions, or no solutions? Well, we know it has one solution, and it says name it. And when you say name it, you're going to give it a coordinate pair. You're not going to name it Mr. Frant or Dr. Frey or Timmy. We're just going to name that solution. And we can look at the point. It looks like it's 3 over 3 up 5. So that would be our solution there. Okay? So we could continue and do more examples, but it's just going to come down to you knowing how to graph and putting it into slope-intercept form or using intercepts to graph these lines and learning how to graph and then looking at the solutions of them. So we're not going to do that. Those ones, if you know how to graph, then you can do those ones easily. Find out how many solutions it has. So our lesson summary here is what is a system of equations and what is a solution and where do you find it? Pretty simple question there. And then our practice problem here, notice I've got a grid for you, graph paper here. We're going to solve this system of equation. So you have to graph those two lines and then give me how many solutions it has and what is the solution if it has one solution. Okay? That is section 6.1, and that's all there is to it. Bring your questions, we'll be ready to roll.